Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 26, One-Step Equations, Addition and Subtraction. Essentially, we're going to be looking at number sentences, and we're going to find out what can we place in the equation to make it, or in the number sentence to make it a true equation, right? To solve the equation. So, again, we say 2 plus a equals 5. We're going to solve for a. A would equal 3, and there you go. You're going to have actual solutions to your number sentences and to create equations out of those. So let's go ahead and get started. I'm going to show you two different ways to do this. One involves a diagram, and the other involves algebra. For me, algebra is always the way to go. It's easier for me, but if you're more of a visual learner, then you may want to use the diagram. So we're going to say a plus 2 equals 8. Now I know this is a pretty simple problem, but I want to just use it, let's start simple. So I'm going to create a diagram here, and this represents 8. Now, that is this side of the equal sign. Now I'm going to create a diagram that represents this side of the equal sign. We know that they are equal, so they have to be the same size. And I know part of my diagram is 2, and then part of it is a. Well, since these are the same size, if you take the 2 away from the 8, you'd have to subtract 2, right? That would mean that you had 6, so a, shouldn't cross that out, a would have to equal 6, right? Because these are the same length. If this is 8, and this is 2 and something, which equals 8, there you go. Now, another way to do that, here's the algebraic way. We have a plus 2 equals 8. We want to get the variable alone. It has to be by itself. We want it to say a equals something. That's called isolating the variable. Since this says plus 2, the way to get rid of that plus 2 is to take away 2. Now, if you do something to one side of the equal sign, you have to do it to the other side of the equal sign. So, we end up with a. 2 minus 2 is 0, so that goes away. Bring down the equal sign. 8 minus 2 is 6. Our answer is a equals 6. Okay, let's do another example. Okay, let's look at b plus 9 equals 15. I'm going to create my 15, which is one side of the equal sign. So this whole thing is 15. b plus 9, I'm going to create as the other part of my diagram. It's the same length as 15, right? Because they are equal. They're the same. So this part is 9. This part here is b. We don't know what it is. But we do know, because we sized them up, right? We do know that b and 9 is 15. So if you take away the 9 here, and you take it away up here, 15 minus 9, you end up with this part has to be 6. So your 6 and your 9 equals 15. Okay? So b equals 6. Algebraically, b plus 9 equals 15. I want to isolate the variable, so I want to get the b by itself. So this is plus 9, so I'm going to do the opposite and take away 9. You have to do it on both sides of the equal sign. I end up with b. That cancels out, that's 0. 15 minus 9 equals 6. b equals 6. Good way to check that then is to take your 6 and plug it back in here. 6 plus 9 equals 15. Is that true? That's true, so that means you're correct. b does indeed equal 6. All right, let's do another one. This one, we flipped it, right? We switched it around a little bit. So instead of 8 plus c equals 12, we have 12 equals 8 plus c. Remember that this means that they are just the same. So a couple of comments there. One, if you really wanted to, couldn't you flip that to 8 plus c equals 12? You could, right? Because that would be the same. So if that's easier for you, go ahead and do it. Nothing's stopping you. Now, I'm going to create my 12 here, which is this side of the equal sign. Now I'm going to create my 8 plus c, which is the same size as 12 because it says they're equal. So I've got 8 here, and C here, the only number, I'm going to make that 8 a little bit better. There we go. So if I have 8 and I'm trying to get to 12, that means C has to equal 4, right? 4 and 8 equals 12. So we have C equals 4. Now, algebraically, we're going to do the same thing that we did before. It's just it looks a little backwards. So we have 12 equals 8 plus C. I still want to get the C by itself. So I'm going to take away the 8. And if I do it on one side of the equal sign, I have to do it on both. So here, those two cancel out, and we end up with C is equal to 12 minus 8 is 4. 4 equals C, which is the same as C equals 4. There you go. If I plug that back in and make that a 4, 8 plus 4 is equal to 12, so that is a true statement. Okay, for subtraction, let's say D minus 5 equals 7. We can use a diagram, but I think that's a little bit more difficult. So I'm going to show you the algebraic way to do this because I think it's super easy that we'll pick up on very quickly. And I can show you the diagram in class. So D minus 5 equals 7. I want to solve for D, right? Solve for D. I want to find out what that means, what that D is, okay? So again, I want to isolate the variable. I want to get this D by itself. Now, since this is, it looks like minus 5, but we can say it's negative 5. If we do the opposite, we have negative 5 and we have plus 5, those will cancel out. So whatever you're subtracting, you add it, and you get the D by itself. Whatever you do on one side, you have to do on the other. So 7 plus 5 equals 12. D equals 12. If I want to go back and plug it in, instead of D minus 5, I'll say 12 minus 5 equals 7. I know that's true, so I have the correct answer here. All right, we're going to do 2 more quick examples. We'll do example A and example B. Example A says E plus 12 equals 20. I want to get that E by itself, so I've got to get that 12 out off of this side. That's got to go, all right? Since that is a plus 12, a positive 12, we're going to take away 12 there, so those cancel out. We'll bring down the E, we'll bring down the equal sign, and since we subtracted 12 here, we've got to subtract on this side of the equal sign. 20 minus 12 is 8. E equals 8. So you see that we saw a plus. What we did was subtract. You see add, you do subtraction. Over here, we see subtraction, so we know we're going to add actually, right? Because we have negative 10, we want to get that F by itself. So when we see minus 10, we're going to do plus 10, and those will cancel out. We bring down the F, we bring down the equal sign. Since we added 10 here, we've got to add it to the other side of the equal sign. We end up with F equals 25. Okay, we're going to go through some more examples together in class, and I can show you the subtraction model that uses the diagram if the diagram helps you. I think it's easier just to add on both sides, but that's just me. Whatever helps you is the important thing. So we'll look at that together. Thanks for watching, and we'll talk to you soon.